xiaogong abor. Your learning journey starts now. Ever wondered how raw data transforms into a purposeful action? We're talking about the DIKWP model: data, information, knowledge, wisdom, and purpose. It's not just a fancy pyramid. It's a semantic network, a web of meaning where intent sits at the top, pulling the strings. Today, we're diving deep into its mathematical soul and its neural correlates. Buckle up. Alright, let's get mathematical. How do we capture this DIKWP magic in equations? Think of it as a 5x5 matrix. Each cell represents how one layer talks to another, or even itself. Data feeding info, wisdom shaping knowledge. It's a fully connected dance. We can model this using graph neural networks, treating each layer as a node, passing messages around like gossip, updating weights dynamically. Need to track interactions over time or between agents. Enter tensor algebra, a 3D tensor. For instance, captures who sent what, to whom, and the semantic content. And finally, semantic topology helps us visualize the structure, how tightly knit these semantic units are. It's about mapping the flow of meaning. Now, where does this all happen in the brain? The mapping is surprisingly neat. Raw data hits your primary sensory cortex, think visual edges, sound tones. That's D. Then, information kicks in via association areas, linking sights and sounds, detecting novelty. That's I. Knowledge. Hippocampus and connected neocortex weaving together concepts like apple, multiple regions firing in sync for that complete semantic. Wisdom resides in the prefrontal cortex, weighing options, integrating value, that's W, and purpose. The motivational system, nucleus accumbens, amygdala, plus the prefrontal pole, setting the goal, driving the whole show, that's P. It's a beautiful parallel. This isn't a one-way street. DIKWP operates in dynamic loops. Upward flow, data becomes info, then knowledge, towards wisdom and purpose. Downward flow, purpose guides information processing, wisdom refines knowledge. It's a self-referential loop, constantly adjusting. This adjustment is key. Relative completeness means the system keeps refining its internal model. But what happens when things go wrong? Enter the bug theory. Errors aren't failures, they're catalysts. They trigger higher-level integration, like mismatch negativity in the brain, pushing the system towards self-correction and potentially consciousness. And don't forget relative consciousness. Understanding isn't absolute. It depends on how well our cognitive frameworks align. It's messy, it's adaptive, it's brilliant. So, how do we actually see this in action? We're building a brain semantic decoder. Imagine tagging experimental tasks with DIKWP labels. What data does it use? What knowledge is needed? Then, capture brain activity using fMRI or EEG. Use a GNN to learn the mapping. Does prefrontal cortex activation correlate with wisdom tags? Does primary visual cortex link to data? We build dynamic weights to simulate attention and learning. The dream. A real-time decoder translating brain states into semantic meaning. This isn't just theory. It's a roadmap for future cognitive neuroscience. That's the DIKWP story, from data to purpose, mathematically and neurally mapped.